Yeah, so good evening everyone. I think this is the place where we stopped yesterday. Yesterday we stopped here, right? No comparison, right? I have here one problem. No comparison is there. Mostly finite automata is possible. Mostly, right? Sometimes may not be. We'll see further, right? But one thing is true. When we say finite automata possible, right? Remaining also possible. Next one, whenever, right? One comparison is needed. Finite automata surely no. Comparison is there means finite automata surely no, right? But PDA possible, PDA mostly possible, and the Turing machine to PDA possible means Turing machine also possible. Next one, right? Two or more comparisons, right? So finite automata PDA not possible, Turing machine may be possible, right? But so remember it is the initial class, I cannot say more than this, right? So further at the end of the entire subject you will get the full clarity. Let's go to today's story. Let's go to today's story. So today's date is, I think yesterday is 24th. Let's go there. What is the date yesterday? 24th. I'll check once. Yeah, this is yesterday is 24th. Yeah, let's go to now. Today 25. Let's go to today 25. In my opinion, today's class is just started now. 25, 8, 26. 25, 8, 26. Yes, I'm starting. Please let me know audio video okay or not. Verify audio video okay or not. 25/8/26 is the today's date. Please verify audio video okay or not. Screen share is visible. Everything perfect. Let me know before proceeding further. Is everything okay? Right? I hope. Yeah, perfect. Thanks. Thanks everyone for confirming. Thanks everyone for confirming. Right? Today's class, let me start. 25/8/26, today's class. So basically, we discussed it till now. Automata, right? TOC contain four languages. TOC contain four languages and four automatas. Four languages, four automatas. Indirectly, directly, TOC contain mainly four languages, four automatas. There may be more, right? Further, we will see. That's what we discussed in the yesterday's class, right? Now let's go one by one. Let's go details one by one, right? So now we are going to the one by one. Please understand everyone. Please understand, right? Write down now. First topic is finite automata. Careful everyone. Finite automata. Finite automata. Topic name is finite automata. MET, I think so. Yeah. Finite automata. So this is the today's class. Be careful everyone, right? Today you will get the full clarity what is finite automata. So remember finite automata, right? Finite automata is basically two types. Finite automata is basically two types. Without output, without output, with output, with output. Finite automata basically two types. Without output, with output. Without output, there are three types, are basically two types. Without output, basically two types. What is that one? One is DFA, one more is NFA. NFA two types. With epsilon, without epsilon. Right? So finite automatas are two types, without output, with output. Without output, there are two types, DFA, NFA. NFA two types, right? With epsilon, without epsilon. Remember, this is called epsilon, right? Without epsilon. Careful everyone. Right? Careful everyone. Small doubt also there, I will help you. Small doubt also there, I will help you. Right? Please listen first. Next one, with output, there are two types. More machine, mealy machine. More and mealy machine. More machine, mealy machine. Right, perfect. More machine, mealy machine. Right, so this is the broadly finite automata will be these many models. If you want, you can give some numbers also. Actually, I divided, but numbers if I give DFA, right, with epsilon, without epsilon, more machine, mealy machine. So in the finite automata, we will discuss about all these five. All these five. And one more, remember everyone. Remember everyone. Everyone try to remember. Please understand once. Any one possible. Any one possible. Out of these five, any one is possible. Right? Try to understand. Any one is possible out of these. So given language is a regular language. Given language is a regular language. Any one is possible. Normally, we'll discuss about these. Right? Remaining two things are not that much important. These are the things which normally we'll discuss. These three. These three we'll discuss. However, we'll see some problems on more and mealy also. So these are not language recognizer. These two people, not language recognizer. They are output generators. These two people are not language recognizers. Given language is regular or not, we don't recognize here. Given language is regular or not, we don't recognize like that. Simply what is the output? So these two are for not language recognition. These two are for output purpose. These two are for output purpose, right? But these three are language recognition. Given language regular or not. Normally we'll discuss this. So suppose isn't that out of these three, any one is possible. Out of these three, any one is possible. So given language is a regular language. Right? This one we don't use for the language recognition, right? This is only for output purpose. These are for output purpose. But however, more mealy is available means automatically DFA and NFA also available. But I don't want to disturb you more. I don't want to confuse you more. Simply, right? DFA possible or NFA possible. Given language is a regular language. And one more thing I want to say to you, right? One more thing, don't confuse. One more thing. DFA possible means NFA also possible. DFA possible means NFA possible. Remember. And one more. With epsilon, NFA possible. Without also possible. So please understand this. But however, there is no linking with output, without output. No need to link also. Please link without output. Inside only link. With output, for every more machine, mealy machine is possible. For every mealy machine, more machine also possible. Vice versa also possible. Right? Those people who confuse a little bit also, I am repeating once again. Finite automata is two types. Without output, with output. Without output is two types. DFA, NFA. NFA two types. With epsilon, without epsilon. And one more thing. DFA possible means NFA possible. NFA possible means DFA possible. What is the meaning? What is the difference? You will see with the help of examples. Next one. NFA possible with epsilon. Without epsilon also possible. Without epsilon possible. With epsilon also possible. And these three people, language recognizers, to check given language is regular or not, to recognition purpose. Language recognizers. Language recognizer, but these are output generator. These two are output generators. Finite automata as a output generator, right? So first three are right. Finite automata as a language recognizer. Second two as right finite automata with right finite automata as an output generator. So you may not get that much clearly, but definitely further you will get the more clarity, right? So now we'll discuss about DFA and NFA. Please concentrate everyone. Please concentrate everyone. Everyone concentrate. Everyone concentrate here. Everyone concentrate here. Right? DFA, NFA. So let me write now. DFA and NFA construction. DFA and NFA construction. Right? Be careful. From now onwards, make sure everyone will get DFA, NFA construction. This is our target. This is our target, DFA, NFA construction. Right? I will try with the help of one problem. I will try with the help of one problem. Please listen, everyone. Right? First problem. Problem 1. Construct, careful everyone, construct DFA for the language L is equal to A power n, where n is greater than or equal to 1. Construct DFA for the language L is equal to A power n, where n is greater than or equal to 1. So this is the problem. How I am constructing NFA, how I am constructing DFA. This is the first problem. In my opinion, actually TOC started just now. DFA, NFA construction. Right? Construct DFA for the language L is equal to A power n, where n is greater than or equal to 1. Now I will try one by one. Please make sure you will get everything in this problem. It is a DFA construction. Right? Yesterday some introduction done. Today, in my opinion, class is just started now. It is the starting of automata. Construct DFA for the language L is equal to A power n, where n is greater than or equal to 1. Now, if you observe clearly this language L, minimum, I think n value 1, n value 2, n value 3, n value 4, and so on. And so on. So if we observe in this language, minimal string is 1 length. 1 length means 1 plus 1 with the two state start automata. Keep the state names whatever names you want, S1, S2. Two state start automata. Because the minimal string is 1 length plus 1 you do with the two states construct automata, right? So S1 to S2 keep an edge. I think minimal string you write here. Starting state keep the initial arrow. Ending state keep double circle. Right? Now if you observe clearly, first A, 1A is accepted. Everyone observe, 1A is accepted. But remember, everyone should accept. In this language, whoever there, everyone should accept. Accepting means what? At the end of the string, you should be in the final state. At the end of the string, you should be in the final state. That is the meaning of accepting. Right? That is the meaning of accepting. Try to understand. So, next one. If you see the second string, single A, S1 to S2, and S2, right? One more A keeps self-loop. This also work out. Two A's are over, starting from starting state. Two A's are over, you are in the final state. Next one, starting from starting state. Three A's are over, you are in the final state. Starting from starting state, 4 A's are over, you are in the final state. So all are accepted. Some people are asking, sir, what about B's, sir? Sir, what about B's? Can you see this one? Construct DFA for the language L is equal to A power n, where n is greater than or equal to 1. He's talking about A's one. He's not talking about B, C. He's not talking anything. See the problem clearly. He's talking about A's only. Right? So in this language, only symbols A's are allowed. Symbols A's are allowed. In this language, only symbols allowed. So remember what symbols are allowed, that is called sigma. They will explain in the problem. What symbols are allowed in this automata, what symbols are allowed, that is called sigma, that is only A. In some language, A's and B's allowed. Then sigma is A comma B. Then sigma is A comma B. In this language, only A's are allowed. Sigma is equal to A. Sigma means alphabet. Every language having alphabet. This automata accept. This automata accept alphabet sigma is equal to A. Means only A's. If you want, you can check in this diagram on the edges, you will see only A's. Okay, that's fine. That is okay. And one more thing, understand here. If you see this automata contains two states. Q is set of states. S1, S2, two states. It is a set. Q is set of states. So two states are there. And one more thing, S is a starting state. It is not a set. One state only starting. S is equal to starting state, that is S1. And one more, F is equal to set of final state. In some automatas, in some finite automatas, multiple finals are possible. So it is a set. In further problems, you will see multiple finite states also possible. But as of now, only one state is final. Right? I hope everyone is fine. I hope everyone is fine. And one more, this is called transition function. Understand? This is called transition function. This is called a transition function. What is the meaning of transition function? Please see this one. Please see everyone now. By applying transition function, S1 on A, I will go to S2. See, S1 on A by applying transition function. You have to apply some function. Then only some work will be happen. On S1, by applying A, if I apply transition function, I will go to S2. See, S1 on A, I will go to S2. In the similar way, right? In the similar way, S2 on A, I will go to S2. This is called transition function. So remember everyone, finite automata is given means these 6 things are given. Sorry, 5 things are given. Finite automata is given means these 5 things are given. That is the reason finite automata is also called as 5 tuple machine. 5 tuple machine. 5 values are given. They will give this diagram, right? They will give the diagram like this. They will give the diagram like this, or they will give these 5 indirectly, directly. Like this also okay, like this also okay. Finite automata is nothing but 5 tuple machine. Finite automata is nothing but 5 tuple machine. 5 values should be given. What is first value? Sigma means alphabet. Means what symbols are allowed. In Hindi language having alphabet. Right? So remember everyone, Hindi language having alphabet. So this machine also having alphabet. Means this machine understand only the symbols which are present in sigma, which is alphabet. Next one, in this automata, how many states are there? Q, which is set of states, S1, S2. Next one, in this automata, what is the starting state? S1. S is the starting state, which is S1. Next one, F is set of final state. Remember, curly brackets are there means set. F is set of final state. Only one state is here, S2. Now, delta is a transition function. What is the meaning of transition function? On one state, by applying one symbol, you will go to another state. That is called transition function. Right? So, construct DFA. I constructed. Why it is called DFA? Can you see carefully? Everyone see. Everyone see. Carefully. Carefully observe. Carefully observe why it is called DFA. See this one. This is called transition table. This is called transition table. See, in the above automata, 2 S1, S2. S1 is a starting state. Starting state means initial arrow. Right? Final state means star operator. It's a one more representation. So inputs are only A. Input alphabet is only A. Can you help me? On S1 by applying A using transition function, S1 on A, I am going to S2. On S2 by applying A, by applying transition function, S2 on A, S2. So what I mean to say is, whatever is there here, I written in the form of a table. I'm not done anything. Something I written common. See, why to write so many times A? See, if you write like this, so many times you have to write A. But here, see, S1 on A, S2 on A. So some minimization. This is called transition table. This is called transition table. Transition table. This is called transition diagram. All same. This is called transition diagram. So remember, right, finite automata is given means either transition diagram or transition table or like this also okay. 3 ways. 3 ways. Either this or either this, either this. All 3 are same. All 3 are same. So in this one, directly they will say starting state is this. Directly you will say final state is this. Directly you will say transitions are these. Directly you will say these are the states. Directly they will say this is the alphabet. But in the case of the diagram, double circle final state. Right? Next one, initial arrow starting state. Right? In the edges, whatever is there. I think right, alphabet. Right? The places where circle is there, right? States. Next one, S1 to S2 by giving A. By on S1 by giving A, I will go to S2. There is an indirectly transition function. One more way is table. In the table, starting state, initial arrow. Final state, star operator. You are applying transition function. Right? So this is the input alphabet, simple A. So all three are correct. Right? And one more interesting thing. Why it is called DFA? I am giving the answer. Everyone observe. Why it is called DFA? Remember, after transition table is over, in the table, every entry contain one person only. Every entry contain one person only. What does it mean? On given state, on a particular state, by applying a particular input symbol, you are going exactly one state. In the transition table, every entry contain exactly one value. That is called DFA. Exactly one, not less, not more. Right? For any finite automata, if you draw transition table, in the transition table, every entry contain exactly one value. Not less than one value, not more than one value. That is called DFA. That is called DFA. But in the case of N of A, there may be a chance of one possible, there may be a chance of less than one possible, there may be a chance of more than one also possible. That is called, right, N of A. What is the meaning of DFA? Every entry contain exactly one value. Right? So see, each entry of finite automata, one value, then it is called DFA. Each entry of finite automata contain one value, that is called DFA. Remember this one, if we can understand, DFA over. In the transition table, each entry contain exactly one value, that is called DFA. Right? Right? Some people are, what about N of A? N of A means each entry contain. So let me write now. Each entry of N of A contain. Each entry of N of A contain, right, one value or zero values or more than one value. More than one. Be careful. Zero values, one value, or more than one value. That is called as N of A. What is the DFA? Exactly one value. DFA. Right? These three possibilities. Let's see this one. All three can happen, or only one also can happen. Everywhere one, then also N of A. Everywhere zero, then also N of A. Everywhere more than one, then also N of A. Mixed, that is also N of A. Right? So I will give some examples. Example for N of A. Example for N of A. Can you see one time? Example for N of A. Just roughly I am giving. Suppose assume in one of the automata. Example I am giving. Above one, below one, no relation. S1, S2. Right? S1, S2, S3. Assume it is a starting state, it may be final state. In every automata, anything can happen. Now, next one. Input alphabet previously A, maybe here AB. Input alphabet is maybe AB. States are S1, S2, S3. S1 is initial. S2 may be final. Right? Now see here. S1 on A, I may go to S3. S1 on B, right? I may go to S1. S2 on A, see this one. S2 on A, I am not going anywhere. S2 on B, I am going to S1. S3 on A, I am going to S1, S2. S3 on B, I am going to S1, S2, S3. Anything can happen. See, sometimes no value, sometimes one value. sometimes more than one value, sometimes more than one value. So this is called, right? Maybe one possible, maybe nothing possible, maybe more than one possible, maybe more than two possible. This is called NFA. This is called NFA. What is the DFA? Everywhere one. Everywhere once. Remember, everywhere one. It is a DFA. But remember, everyone, every DFA is NFA also. Right? What is the NFA? See, so NFA one also possible. NFA, remember everyone, NFA one also possible. DFA is always one. NFA, there may be chance of one also. So every DFA is NFA. Every DFA is NFA. Remember. So I'm writing now. If someone is DFA, assume someone said that I have a DFA. What is the equivalent NFA? DFA means NFA also. But NFA doesn't mean that DFA. Because, right? Because see this one, DFA is one only, right? But NFA 0 also, 1 also, 2 also, 1 there. No issue. No issue. But NFA means 0 there, 1 there, 2 there. Right? 0 there, 1 there, 2 there. How can I say 1 there? So this side is not possible. NFA is not DFA, but every DFA is NFA. Remember. So this means if anyone is not getting, I am writing the first note 1. I am writing the note 1. Try to understand everyone. Each DFA is NFA. But each NFA need not be, sometimes maybe, need not be DFA. Remember this note. Remember this note. Each DFA is NFA, but each NFA need not be DFA. So remember, it is a NFA, but not DFA. Right? And one more. See this one. It is a NFA, right? It is a DFA also. Remember, some NFAs are DFAs. Some NFAs need not be DFAs. Remember. So every NFA I cannot say. See this one. Every, in the place of each, na, you can write every. Every DFA. Every DFA. Every DFA is NFA, but every NFA need not be DFA. Every is better. Every NFA need not be DFA. I hope everyone is very easily I said. Very easily I said. Sir, finite automata given means what is given? Maybe this is given. Maybe this is given. Maybe this is given. Anything, all three are okay. So, sir, what it is called? Transition table? Sorry, transition diagram. What is called? Transition table. What is called? Normal. I think normal. 5-tuple representation. 5-tuple representation. So, right, finite automata is also known as 5-tuple machine. 5-tuple machine. So, sir, in this model, which one is the final? So, they will say clearly, final states this. Right? Input alphabet is this. Set of states are this. Starting state is this. Transition function is this. They will give in the problem itself. Clearly, they will say transitions are. They will say clearly. But here, double circle, final state. Initial arrow, starting state. On the edges, alphabet. Right? Next one. S1 on A, S2, transition. Like that. Here, initial arrow, starting state. Star operator, final state. Next one. In the table, each entry contains exactly one value, DFA. DFA means NFA. In the transition table, each entry contains either 0 values or 1 values or 2 values are mixed, right? That is called NFA. NFA means non-determinism. Name itself saying, na? NFA, N means non-deterministic. N means non-deterministic. Means nothing clear. Is it 0 entry or 1 entry, 2 entry? Nothing clear. NFA means non-deterministic finite automata. What is the meaning of DFA? Deterministic finite automata. Deterministic finite automata. It is deterministic. What I mean? Everywhere one. Everywhere one. You also in life. Everywhere one choice. You are deterministic. Right? Normally humans are not deterministic. Machines are, right? Inside the computer, inside computer. Right? Every program is a deterministic program because you will see fixed output. Output will not change. Fixed output. But humans are non-deterministic. The reason is this, humans are so volatile. Many behaviors are there. So non-deterministic finite automata means some ambiguity. What is the ambiguity? Sometimes no value, sometimes one value, sometimes two values, sometimes three. So that is the non-deterministic. Remember, every DFA is, I written also, every DFA is N of A, but every N of A need not be DFA. Okay, I think you got some idea. Now I will go to the one problem item. Problem 1 item. Let's go to problem 2. Careful everyone. Problem 2. From now onwards, make sure everyone listen. Problem 2. Construct minimal. Remember, minimal. Construct minimal DFA for the language L is equal to, construct minimal DFA for the language L is equal to, be careful, A power M, B power N, where M comma N greater than or equal to 1. Be careful. So remember DFA, our goal is DFA. Construct minimal DFA. Why it is called minimal? We'll see. I will explain that also. Construct minimal DFA. Minimal we'll see, right? But first concentrate DFA, right? So what is the way? Understand first. First write the language. This is the second problem you are doing. First write the language. Language L is equal to. First write the language. I think M value, N value you can take 1. So AB. Right? I think M value you can take 2. Right? N value may be 1 or vice versa. M value 1, N value 2. Right? Next one, double A, double B also. Next one, triple A, single B. Triple A, double B. Next one, triple A, triple B. So like that many. But if you observe clearly, right, what is this language is so many A's followed by many A's followed by many B's. Means M A's followed by, right, N B's. And remember, it is M, it is N, no relation. Right? 5 A's are there. How many B's? Any number, but minimum 1 B. Minimum 1 A. So many B's. So be careful. So this is the language. Now, if you observe clearly this language, everyone try to understand. First of all, if you want to construct a DFA, for any language, first understand the language. So if you understand this language, right, try to understand. If you understand this language, only A's not allowed. Only B's. This language understand properly. Only B's not allowed. Next one. A's followed by B's. Any number of B's, no problem. Possible. Next one. A's and B's equally possible. Remember everyone. A's, B's not possible. Means A's followed by B's possible. B's followed by A's not possible. B's followed by A's not possible. Try to understand. So what this language is saying is A's and B's compulsory, but order also important. What is the order? A's only should come first. B's only should come last. Remember, after seeing first B, you cannot see A's further. After seeing the first B, you cannot see A's further. Right? Any number of A's you want to give first A's, then B's. Okay, fine. You understand the language. After understanding the language, right, find the minimal string. Minimal string is to length. 2 plus 1, 3. 3 states start automata. Understand everyone. Everyone try to understand. With the 3 states start automata, I am starting. S1 state, S2 state, S3 state. with the 3-state start automata. Okay, I started. So remember, on the edges keep the minimal string. On the edges keep minimal string. On the edges keep minimal string. AB is the minimal string, 2 length, 2 plus 1 with 3-state start automata. Okay, on edges keep minimal string. First symbol is A, second symbol B, you get. So last state make it is final, first state make it as starting. Okay, everything is fine. So if you observe clearly, listen, if you observe clearly, first string successfully over. Right? You have to convert this diagram. So first diagram, see this one, whatever diagram you drawn initially, it will accept the first one. Right? You have to do some changes so that further will come. Let's see. Minimal diagram is like this. Next minimal. See the next example, next input, then you can plan. Can you see this one? After 1A, before going to B, if A's will come, I think you can keep loop here. I think so many ways. Remember, S2 purpose is S2 purpose. Every state will remember something. I'm writing here. Each state, it is a very, very important. Each state remember something. Each state remember something. Each state remembers something. Please be careful. Some people are asking, sir, what S1 state will remember? S1 state remember. Till now, A is not came. What is the S2 state remember? S2 state remembers minimum 1A guarantee. Remember, loop may come, may not come. We are not sure. But S2 guarantee that already sync 1A came. Minimum 1A came. Minimum 1A came. Means string already started with A. S2 indication that string already started with A. Means minimum 1A happened already. What is the S1? Nothing happened till now. What is the S2? Minimum 1A happened. Minimum. Maybe more also. Next one. Some people are asking, sir, what does the S3 indicate? S3 indicate minimum 1A followed by minimum 1B. So remember, minimum 1B already happened. But before B is yes, according to this language, before B is yes required. So when you come to S3 means minimum 1B over. 1A followed by 1B, right? So what I want to say, every state will remember something. When you come to S3, B's are already started. 1B followed by any number of B's. Keep in the same final. Right? Now if you observe clear, A, B, A here, one more A, self loop here only, followed by B here. String is over, it is accepted. Next one, single A here, followed by 1B here, followed by one more B, self loop. Next one, single A here, one more A here only, single B here, one more B. I think here this is completed. If you want, you can check. All perfectly fine. Now some people are asking, sir, every string accepting, where is the issue? Now listen, if it is a valid diagram, all valid things should accept. And one more, every invalid thing should reject also. It is invalid, should reject. It is a invalid, should reject. Right? It is a invalid, should reject. It is invalid, should reject. Is it rejecting or not? Let me check. Listen everyone, is it rejecting or not? Let me check. So only yes, I came here. See this one, triple A over, I am at here. Triple A completed, you are at S2, which is non-final, rejected. At the end of the string, if you are in non-final, rejected. So this is rejected, perfect. Invalid, rejected, no issue at all. Invalid should reject, yes, no issue, perfect. Invalid should reject, yes, rejected. Some people are asking, what about this, right? B, sir. Sir, on S1, no B also. Sir, on S1, no B also. Remember, DFA means on each state, every symbol means each entry should contain. Some people are asking, sir, can you draw for this one? Transition table, let me draw. According to my opinion, problem is over, but it is not DFA. Can you see this? Transition table, I am writing 3 states, S1, S2, S3. Right? Input alphabet, if you see, A's and B's. A's, B's. Understand everyone? So S1 is starting state. S3 is final state. See the diagram and top. S1 on A, S2. S1 on, right? S1 on B. Listen, everyone. S1 on B you are not given. So remember, S1 on B not exist means it is at N of A. It is not D of A. It is N of A. Whatever you constructed, it is not N of A. It is D of A. Sorry, it is a N of A. It is not D of A because S1 on B not there. Sir, all are accepted, na? Yes, all valid things are accepted. But invalid things should reject also. See, S1 on B. Directly S1 on B comes. You didn't given anything. So it is N of A. N of A means, because some people are asking, sir, according to this language, starting B will not come. Why should I give? Okay. That is the meaning of N of A. N of A means necessary things you will give. You don't take unnecessary headache. Sir, in this machine, S1, B never come, na? Why should I write? That is the meaning of N of A. N of A means user comfortability, user friendliness, necessary things only we will do. So every human, in my opinion, right, they are like N of A. Every human, in my opinion, like N of A. Humans don't have any, right? Humans don't have any proper deterministic behavior. They are non-deterministic behavior. Necessary, then only they will do. So, right, they will take the water bottle, they will buy the water bottle, they will drink, they will throw. They don't keep in the proper place because their behavior is that even though dustbin is there, they don't keep. So same thing here. See this one, S1 on B. Sir, according to my language, B never come now. Why should I write? Keep that. Yes. So this is called N of A. Right? This is called N of A. Next one. Some people are asking, sir, with this machine, all valid things are perfect now. Invalid things I am not writing. So S1 and B I am not writing. Some people are asking, sir, if you don't write, where they will go? The things which you didn't return, they will by default will go to, right? They will by default will go to dead state, which is called trap state. Means, which is nothing but invalid. Let me write the same diagram. Careful, try to understand. A, B, S1, S2, S3. Let me write the same diagram. Everything same, right? So let me write. So if you see the above diagram, let me write S1 on A, S1 on A, S2, S1 at S1 on A, S2, right? S1 on B, not there, not there. But remember, in the case of DFA, you have to go somewhere. Sir, not required, but still you have to go. That is called dead state. So S1 on B, I may go to dead state. Unnecessary people will go to dead state. Means string rejected. S1 on B actually not required, so that just go to dead state. Dead state, some state name, dead state. Right, next one. Some people are asking, sir, can you go to S2? When you say S2, according to this language, S2 means already A's happened. After A's, you may get A's are followed by B's. I think S2 on A, S2 on B, S3, same, no problem. Now, can you see the S3? Can you see the S3? S3 means already B's, already one B you've seen. After seeing one B, so many B's only allowed. What is the meaning? S3 on B, S3, okay. But on S3, you never see A's. But in the case of DFA, you have to say. Where are you going? I think not required, go to dead state. But here S3 on B, S3 on A, not required. Not required means keep gap. No extra burden. Not required, don't write. In the case of N of A, not required, then still you have to write. Go to dead state. That is called dead state you are going. Sir, in the case of DFA, I think some states you have to take extra. Yes, DFA may contain more states. Sometimes equal states, sometimes maybe DFA more states also. Right? Some people are asking, what are the D? D also one more state. What is the D behavior? Some people are asking, sir, D on A, where you are going? Dead state behavior is dead only. Dead on A, dead only. Dead on B, also dead only. Dead means dead. For the dead body, you give any medicine. A and B are like medicine, right? So already is dead. You give any medicine, no use, right? Please be careful. This is called DFA. This is called DFA. So let me write the same diagram, DFA diagram. S1, S2, S3, right? Dead state. If you want, you can write S4 also, no objection. S4 also you can write. Names, see, state names doesn't matter. You give anything. S1 on A. Can you see the above diagram and top? Same thing. S1 on A, S2. This is a same only. This is B. This is B. This is B. Okay, fine. Now S1 on A, dead state. S3 on A also dead state. Dead state behavior, it will go itself. Some people are asking, how can you write S4? Some state name, yeah, you write anything. Sir, why it is called dead state? Why it is called dead state means if anyone come here, unfortunately, if you come to this dead state, you cannot go to final. See, from here, there is a hope of going to final. See, I can go. From here, you can go to final somehow. From here, already final. Everyone goal is going to final. Huh? Every state goal is going to final. See, on the state, if you give some good input, you may go to final. On the state, if you give good input, you may go to final. On the state, already the state is final, no problem. But on the state, you give anything, you never go to final. Because see the edge direction. See the edge direction. Why S4 is called dead state? Unfortunately, if you reach S4 state, you never go to final state. Right? That is the reason it is called as dead state. Not because of name, behavior. S4. S4 means dead state. Dead state will go to itself. Next one, S1 on B. S1 on B, dead state. Next one, S3 on A. S3 on A, dead state. Right? So, as usual, same. It is a final, it is a starting, this is the DFA. This is, right? This is not there. In the case of N of A, you no need to write. In the case of N of A, you no need to write dead state. Dead state means, right? In the case of N of A, bindas life. Unnecessary headache not required. Unnecessary headache not required in the case of N of A. Sir, N of A gaps are there? Yes. What is the meaning of gap? They are unnecessary. Why unnecessary? See, in this automata, never S1 starting state itself B's never arise. So S1 on B never arise gap. Right? So sir, S1B you are not saying DFA, N of A don't talk. N of A will talk only necessary things. Unnecessary thing it don't talk. Why? By default they will go to dead state. You no need to say. Someone is keep on calling, I am not lifting. Someone is keep on calling, I am not lifting. So when you are not responding, by default rejected only. By default it is rejected only. Same thing. S1 on B according to language, S1 B never come. But you have to cover, na? N of A don't cover. If you don't cover, where it will go? By default it will go to dead state. You don't need to write. So for this problem, N of A 3 states. For this problem, DFA 4 states. It is the DFA. DFA, unnecessary things also you have to cover. So suppose in that someone is calling. If it is a DFA, I have to lift and say, I hate you, cut the phone. In the case of DFA, if you want to behave like a DFA, someone is calling whom you don't like. Still you have to lift the phone, you have to say, just get shut up. Just get out. Go to hell. Just die. You have to say something like this. But in the case of N of A, right, that is the reason human beings are very smart. Unnecessary, they don't respond. Unnecessary thing, they don't respond. S1 on B, I think N of A, na? In my language, B never come. So don't respond, means gap. S1 on A, S2. Next one, S2 on A, S2. S2 on B, S3. Okay. S3 on B, S3. Okay. S3 means already you've seen first B. One more A comes. I think S3, A never come. So keep gap. Why are you keeping gap? Gap means rejected. Why? They will by default will go to dead state. But in the case of DFA, you have to say, where are you going? Now some people are asking, how can you say S4 is dead state? You see, from S4, you will never reach final. There is no way to go to final. From S4, can you go to final state? No way. What is the meaning of dead state? If someone is already dead, he never become normal. If someone went to dead state, he never become normal. Some people will say, problem is that they got some issue in life. As a human in life, you will get issues, right? You will also get issues. I will also get. Some people, what they will do is, in life, little bit problem also will come. They will die. They will do suicide attempt and they will die. Arey, bhaiya, dead state is not a tourist place. Whenever you have some issue, some problem, go to tour. Go to some tour, enjoy and come back. And try to solve the problem. Whenever some problem will come, people will die. Arey, bhaiya, death is not a tourist place. What is the meaning? If you die, you cannot come back. But if you go to tour, you can come back. Sir, I have some, my brain is not working, sir. Reddy, sir, my brain is not working. If your brain not working, go to movie. If your brain not working, sleep. If your brain not working, talk with friends. Sir, my brain is not working. I cannot handle this pressure, sir. Sir, I want to die. Arey, death state is not a tourist place. You cannot come back. If you die, gone. Maximum in the newspaper, if it became viral, one day one news will come. So and so person, because of some reason, some death happened. Then below, some people will say, RIP, rest in peace. Right? So stay blessed always. I wish you will be happy at least in the heaven. So one day they will keep 20 comments, 30 comments. Over. It is not a tourist place. After death though, if you say I will come back, it is not possible. So S4 is exactly dead state. See, in the S4, if anyone come to S4, they cannot talk with people. See, from S4 you cannot go to S1. From S4 you cannot go to S2. From S4 you cannot go to S3. Dead state means gone. Dead state means you will talk yourself. No one can listen also. Sir, dead body can talk. Yes, it is talking itself. Sir, I am not able to hear. Arey, bhaiya, he is not a normal person. He is a dead body. He will listen himself. S4 is calling itself. S4 on A, S4. S4 on B, S4. That is the meaning of dead, na? You want to listen. Dead body talks also. Sir, doctors will listen dead body talking. No, dead body talking will be done by dead body only. Other people cannot. Doctors are giving A medicine, B medicine, no effect. Doctors are giving A medicine, B medicine, no effect at all. No effect at all. Right? Fine. So it is a DFA. Some people are asking NFA, DFA. Who will cover unnecessary DFA? If you want to be deterministic, you have to cover unnecessary thing. Every time, see, there are some people I see in my life, they are deterministic in the life. What is the meaning? If you send mail, they will respond. If you send one WhatsApp message, they will respond. Some people are there very careless. You can say they are smart also. Some people are very careless. You can say smart also. What is the meaning? Necessary thing, they will reply. Unnecessary, they don't reply. That is called NFA. NFA means smart people. Sir, someone sent some message, I didn't like it. So I keep quiet. It means you are NFA. Sir, someone sent some message, I didn't like. Then I shouted back. Someone sent some message, I liked it. I said I liked. Someone sent some message, I didn't like it. I said I didn't like it. Everything you are responding one way, that is called DFA. That is called DFA. Sometimes you are responding, sometimes pin drop silence. Keep quiet. That's called NFA. So NFA construction easy. NFA means what? Only necessary things. Only necessary things. Only required things. Only required things covered. Here, all covered. All covered. Required things covered. Only required things covered. Here, all covered. All 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 cove Required or not doesn't matter. All covered. Sir, someone is shouting. Still, I have to say, right? You are idiot. You will respond, I am not. You are a good person. Yes, I am. You are a nonsense. No, I am not. So everything you are responding, that is called DFA. Right? If you respond only necessary, that is called NFA. Right? NFA only required covered. Only required things covered. Right? Next one. All covered. All covered. Right? Here only required things covered. That is the reason. That is the reason NFA is easy. DFA difficult. DFA construction difficult. Means some extra things you have to cover. So if anyone say what is DFA, everywhere in the transition table, everywhere in every entry, one person only there. That is called DFA. Next one, why everywhere 1 1 1 1? No ambiguity. Like also I have to say, not like also I have to say. If anyone say you're right, if I say there are some girls are there in my life, I don't know how people will take like this. There are some girls in my life. I proposed. I said, I love you. Then what happened is, one day yes, one day no. Sometimes say yes, sometimes say, "Arey, bhaiya, enough ye behavior." Right? Some girl I proposed, and the girl said, no, no. Means I mean, some people will behave like a DFA. Some people will behave like a NFA. Arey bhaiya, so don't think badly. So Reddy sir is a very bad person. He proposed. No, don't say like this, bhaiya. Just for your understanding, I said. Right? So what I mean to say is DFA, DFA. Every straightforward. No. Yes. No. Yes. But NFA, NFA. Sometimes yes. Sometimes no. See, sometimes dilemma. Sometimes yes, no also. Right? There are two possibilities also. Okay, fine. I think you got it. What is the problem? Construct minimal DFA for the language L is equal to. I constructed minimal DFA for states. I constructed minimal DFA for some people are asking, sir, 4 states you done. How can you say minimal? I can draw the same diagram with 5 states also. If you want, you can check same meaning. S1, S2, S3. Can you see this? A, B, A, B. That's fine. S1 on B. S4, which is the dead state. See the answer. Right? Next one. S3 on S3 A never happened. If A happened, S5 itself. So 2 dead states you can take. Both are doing same meaning. Both are doing same meaning. Try to understand. So remember, it is also DFA. It is also DFA, but it is not minimal DFA. It is not minimal DFA. Both are doing same. But it is a DFA. It is a DFA. It is a DFA. Minimal DFA also. It's a minimal DFA also. Without changing the effect, meaning is same. Right? You are here you are wasting the states. Why 2 dead states? So same thing done by one person. Then why are you taking 2? Same thing done by one person. Then why are you taking 2? Dead state purpose 1 is enough. Why are you taking 2? So right, above diagram also correct, below diagram also correct. Below diagram is not minimal DFA, DFA. Above diagram is DFA. So for this problem, construct minimal DFA for the language is this. So I think how many states are there? 4 states. Right? This is also correct. It is a DFA but not minimal DFA. It is a DFA but not minimal DFA. Do you have any objection? Let me know. Do you have any objection? Make it fast. It's a problem number 2. It's a problem number 2. 2 problems I done. 2 problems I done. Can we go further? Can we go further? 2 problems I done. Can we go further? Yeah, can we go further? Let's go to P3. Next one, P3, third problem. Two problems I done. Let's go to third problem. Let's go to third problem. Be careful. See the third problem. Listen. Before going to third problem, just I want to say one thing. Listen carefully. ABC string. ABC string. Length of the string is 3. Only string A length is 1. Right? A, B, C, D length is 4. Double A length is 2. Right? Now see the answer. Epsilon, this is the epsilon, length is 0. Remember, he is a special person in the total TOC. He is the hero of the TOC. Hero of the TOC subject. Hero of the TOC subject is epsilon. Total TOC subject run by epsilon only. Some people are asking, what is epsilon? Epsilon is a string whose length is 0. Let me write. Epsilon is a string whose length is 0. Or one more thing, epsilon is a special symbol whose length is 0. So he is the main person. In the TOC, main actor is this person only. Epsilon is the main actor. Please be careful. Now I am going to the P3. Careful. Problem number 3. Construct minimal DFA for the language L is equal to A power, everyone understand, A power n, where n is greater than or equal to 0. Remember, where n is greater than or equal to 0. Understand. Some people are asking, what about this? Let's check. Here, language L is equal to, I think n value 0 also you can take. A power 0 means 0 A's means epsilon. A power 1 means 1 A. Next one, A power 2, n value 2 A's. Next one, A power 3 A's. And so on. Right? And so on. A power 10 A's. Right? And so on. Now understand. Everyone be careful. It's one of the nice problem. Can you concentrate? Remember, we want DFA. Everyone try to understand. DFA we want. DFA, not NFA. Right? Minimal string is epsilon. Epsilon is 0 length. Right? Then 0 plus 1 with one state start automata. One state houser. Take S1. That is the starting state. Remember, S1, take starting state and make that as the final state. One state you have to start the automata. Yes, I started. Sir, one state houser, starting state, final state, same. Now some people are asking, sir, what it is accepted? Remember, in any automata, starting state, final state, same means epsilon accepted. Remember, start state is equal to final state. It is a very important. That means epsilon accepted. It is a by default because it is a 0 length. In any finite automata, need not be this, right? PDA also. Any machine you take any machine. In any machine, in any machine, starting state is equal to final state. Yeah, let me write now. In any machine or in any machine and automata same. In any automata, or in any machine, starting state is equal to final state. Epsilon is accepted. It's a very, very important. Some people complete the total TOC subject. Some student will complete total TOC subjects. Finally, they will say, right, how epsilon is accepted. Remember, starting state is equal to final state. Epsilon accepted. So in this language, minimal string is 0. Right, 0 plus 1 with one state start automata. How? Starting state, final state keep same. Means by default epsilon accepted. Okay, epsilon is done. Okay, next one. What about single A, sir? Let's keep self loop. Single A over. You are in the final state accepted. So double A over. You are in the final state accepted. Right, triple A accepted. So many A's accepted. And one more thing, if you observe total problem, anywhere you see, nowhere B's are there. So alphabet is only A. See this. Alphabet is only A. This means sigma is equal to only A. Nowhere you see. See, if you see the P3 started here. P3 started here. Nowhere B's are there. See, sigma is only A. So if you construct a transition table for this only one state, starting state, final state, say symbol is A, S1 on A, S1. See, it is a DFA. So it is a DFA. And one more, less than one state, not possible at all. So it is a minimal DFA also. This is minimal DFA. For the given problem, minimal DFA contain one state. Answer is one state. If you want, you can check everything is accepted. Everything is accepted. P3 also done. Let's go to P4. Be careful everyone. Construct minimal DFA. Remember minimal DFA. For the language L is equal to all strings of A's and B's where each string starts with A. Remember, string is all strings of A's and B's. Every string contains some A's and B's, but where each string starts with A. So let's understand the language. First, understand the language. What exactly this problem is? Understand. Language L is equal to every string starts with A. So A first, only A, okay. A followed by A also okay. A followed by B also okay. A followed by AA okay. A followed by AB okay. A followed by BA okay. A followed by BB okay, and so on. Just wait. Someone is came. Just wait. Right, fine. So every string starting with A is the story. So minimal string is one length. So directly, what this problem is saying is, starting with A, afterwards anything. So can you, like some people are asking, what is the meaning of anything? Sigma means alphabet. So for this problem, what is the sigma? For this problem, sigma is A comma B. Right? So sigma means A comma B, sigma star means A comma B combination, anything. A comma B combination, anything. So remember, sigma star means, I'm explaining here itself. Sigma star means A's and B's, any or all combinations. All combinations. Only A's you take, only B's you take, A's followed by B's, B's followed by A's, everything. All all strings of C, A's and B's, all combinations. That means only A possible, only B possible, A possible, AB possible, BA possible, BB possible, and so on. All. Right? A followed by anything. Indirectly, this language is A followed by anything. This can, if I simplify, A followed by anything. Na? Sigma means what? Sigma means what? A comma B whole star. So here comma means in the TOC, comma means plus operator, A plus B whole star. A comma B in the TOC it is called A plus B. Comma means either A or B. A or B. Here A plus B. So like that. A followed by anything. This is called as sigma star. Sigma star means A's and B's everything. A's and B's all combinations. Okay, fine. So don't think much. Our concentration is this. Our concentration is this. Minimal string is one length. Understand everyone? Minimal string is one length. 1 plus 1, 2 states. So we have to start automata with 2 states. I'm starting. S1, S2. So A, come here. Now listen, if you come to S2 means already string started with A. S1 means string is not started at all. S1 means string is not started at all. S2 means already string started with A. After string starting with A, anything, no objection. After string starting with A, anything, no objection. Anything, no objection. See this one? String starts with A, then go to S2. S2, anything is okay. But remember, if you stop here only, this is N of A. Why? This is N of A. Why? S1 on B, you are not saying. But according to this language, starting cannot be B, right? That is the reason I am not covering. If you don't cover, that is called N of A. Some people are asking, sir, cover that also because we want DFA. No? It is a cover that I am covering. I am covering. So on S1, B cannot happen. If any string is starting with B, according to this language, it should be rejected. So go to S3 state, which is the dead state. Dead state behavior, it will go itself. It is a DFA. So for this problem, DFA 3 states. Remember, it is a minimal DFA. Some people are asking why it is minimal. If you want, you can delete anything. If you delete this one, it will become A, right? N of A. If you delete this one, I think some problems will come. So it is a minimal DFA. Every state is important in this diagram. Minimal DFA. It is a minimal N of A. It is a minimal N of A. Everything important here, but it is a N of A. It is a minimal DFA. For this problem, minimal N of A contain 2 states. For this problem, minimal DFA contain 3 states. Right? Now, some people are asking, for the above problem, if you observe clearly, A followed by anything, this is called regular expression. Regular expression. So, A followed by, see this one, A followed, here concatenation. A followed by, right? In the A, B, anything, right? Whole star. So, remember, this is called concatenation. This is called concatenation. Connecting purpose concatenation. This is called union operator. This is called clean closure. Right? Regular expression. So don't think much. Right? Simply whatever opera is there, just I written the regular expression. Right? You will see many times. Afterwards, you will see many times. Don't worry. You will see many times. Right? Fine. I hope everyone got it. This one, right? This one I will repeat many times. Don't worry. This one I will repeat many times. Regular expression I will repeat many times. Right. Now some people are asking, okay, sir, for this, ready sir, for this purpose, what is the regular expression? I think so many A's, na? A star. A star. Remember in the star, because the star means what? A can be any number of times, which this star indicates 0 also. If you don't want to take, don't take also. 0 also will come. Star means 0 times also. Star means one time also. One time A you can take, 2 times A you can take, 3 times. Star means you can take 0 times also. What do you mean? This also possible. Some people are asking, sir, here, sir, ready sir, in this problem, A followed by sigma star. Sigma means A comma B, na? A comma B, I don't take anything. That is the reason, minimal A coming. This can be nothing also, means epsilon. You are not taking anything also, epsilon. So simply A will come, right, like that. So I will explain further. Anyhow, I will explain further, right? Let's take problem number, this is a problem number 4. Let's go to problem number 5. Construct minimal DFA for the language L is equal to set of all strings of A's and B's where each string starts with A and ends with B. This is a problem. Construct minimal DFA for the language L is equal to set of all strings of A's and B's where each string starts with A and ends with B. Right? There is a problem. Now understand. First of all, before going to the answer, write the language first. Write the language first. What is the language? Can you check here? What is the language? Starts with A, ends with B. Starts with A, confirm. Ends with B, confirm. In between, nothing. Okay, no issue. In between, nothing. Next one. Sometimes starts with A, ends with B. In between, only A, okay. Only B also, okay. Next. Starts with A, ends with B. In between, 2 A's, 2 B's. Starts with A, ends with B. In between, triple A to triple B. Starts with A, ends with B. In between, 4 A's to 4 B's. Anything you can write. So finally, what this language is saying is, everyone understand. What this language is saying is, right? Starting A, confirm. Ending B also confirm. In between, anything. Anything means what? Sigma star. Right? Which nothing but A confirm, B ending confirm. Sigma star means A plus B holds. It is regular expression. Regular expression. Right? Remember, here concatenation there, here also concatenation there. Yes, right? In between anything can come. In between anything can come. In between anything, starting symbol, ending symbol, confirm. In between anything means sigma star. What is the sigma? A comma B. A comma B in the mathematics, in the TOC, A plus B. Right? So sigma star, A plus B whole star. A plus B whole star means A's and B's, every combination. Star means you may not take this also. It is a 0 time. You don't take anything also possible. Star means don't take anything here. Right? Star contain 1 also. You can take 1 time also. You can take 2 times also. Anything is possible here. Okay, I think you written the regular expression, everything okay. But remember minimal string for this problem. If you observe minimal string, 2 length. So 2 plus 1, 3 states. With the 3 states, you can start. 3 states start automata. It is not final one. Start. 3 states start. Start automata with 3 states. So we'll start now. Let's see here. Let's see. So remember, it is a crash batch. For GATE CSE, it is a crash batch. For GATE CSE, it is a crash batch. Remember, only 4 classes on the YouTube. Only 4 classes on the YouTube. Remaining all will be on the EPT platform. So, right, so TOC subject is going on after TOC, right, some other subject. In the crash batch subject will be over faster. Crash batch subject will be over faster. So please be careful. So crash batch is started on the 21st, 7:30 every day. Every day 7:30. Every day 7:30. Right? And one more RIC batch starting on 28th. 28th of this month RIC starting. Remember last year 40 plus questions came. 40 plus questions came. Some right by including the RIC and test series. Right, almost like 50 questions came. Only RIC 40 plus questions came. So this is going to be very useful in the last 6 months. For practice purpose, this is the best course because most expected questions are there. RIC course contain most expected questions. So if you are serious about GATE examination, this course will be really beneficial. RIC and test series combinedly is going to be a game changer to your GATE rank. 28th onwards starting, so please use it. Right, next one, EPT. Why EPT? Many people are asking why EPT. So live classes also there, recorded also there. And because in RIC, most of the questions are expected. Last year, 40 plus questions came. This year, we are expecting right 50 plus questions. Guaranteed questions are there. Directly or indirectly, guaranteed questions are there. Directly, indirectly, guaranteed questions are there. Affordable prices, very less prices. Please go and explore the EPT. Very less prices are there. We are guiding, right? I'm guiding from 2007 onwards. I'm guiding the students, right? Really useful using this kind of experience. 2007 onwards, I'm guiding. Using that experience, we are able to frame guaranteed questions. Most of the questions in the right RIC course test series going to be come directly, indirectly. Exam oriented preparation. We don't say some nonsense here. All the things are exam oriented only. Now come to our problem. Starting with A, ending with B. Understand? Starting with A, ending with B. Starting with A, ending with B. In between anything, right? So minimal string is to C. This can be anything. This can be anything. Anything means this can be epsilon also. Remember, you are not taken anything means in between 0 length you taken. So this will goes to A is 1 length, epsilon is 0 length, B is 1 length, overall length is 1 plus, right? If you see 2 length, AB. So in between epsilon, you can take epsilon also in between. Because whole star, na, everything is there. In between, you can take 1 length also. In between, you can take 2 length also. In between, you can take 0 length also. In between, you can take 10 length also. Anything. So minimal string is 2 length. Minimal string is 2 length. 2 plus 1, 3 states start automata. I'm starting. S1, S2, S3. S3 is final. S3 is final. Right? So starting with A, ending with B, in between anything. But remember, it is DFA. S2 on B you written. See, starting with A, ending with B, in between anything. But already S2 on B there. Remaining A only cover. Remaining A only cover. Right? Next one. Already string is ending with B. Some more B's will come, no issue. Starting A followed by so many A's, right? Ending B followed by so many B's. Okay, everything is fine. Now remember, you are at S3 means already ending is B. Already ending is B. You are at S2 means already starting with A. S1 is saying that string not started at. S2 saying that string already started with A. S3 saying that string is ending with B also. Whenever string is ending with B, one more B come, no problem. Ending with B, no problem, still final because accepted only. One more B, no problem, still accepted only. Suppose unfortunately A, see ending should be B, na A, so go back. Where again B comes come, right? So now you are in the S2 state. But string already started with A. You cannot go to S1. Already string started with A. Starting I cannot change. But ending is keep on changing. See, ending is B. Stay in the S3. Ending A, na, but it should be B. So then wait in the S2. After S2, again B comes. Go to S3. Again B comes S3 only. When you are in the B, ending B, suppose A, again wait in the S2. So this is the way. If you want, you can check, everything will be accepted. Starting with A, come to S2. Afterwards, many A's, S2. Next one, ending with B, go to S3. String is accepted. Suppose some more B's are coming after ending with B. Some more B's, no problem. Suppose ending is A. Remember, ending can change. Ending is B, S3. But ending is not B, then S2. Once a string is started with A, you cannot change it. Starting is always A. But ending can change. See, ending B's are coming, ending A's are coming. If ending is A, wait in the S2. Ending is B, go to S3. So like that it is going on, right? Now the only problem is, remember, the only problem is, if string starts with B, according to language, it cannot start with B. It should start with A. Suppose it starts with B. Go to dead state. If you want DFA, string starting with B, according to this language, it is impossible. So DFA, it is DFA. States are 4 states. If N of A, minimal DFA, remember. If minimal N of A, then what is the answer? 3 states. Please check everything accepted or not. In the N of A, listen, in the N of A, valid strings accepted. Invalid string, we may reject. Invalid string we may reject, we may keep quite also. Keep quite also rejected. In the case of minimal DFA, see this one. In the case of minimal DFA, valid things, yes. Invalid thing, no. But here, invalid thing, no, or one more thing. Invalid thing, he will say no. That is a one thing. No means non-final, you will go. One more thing is invalid, silent. No response. In the case of N of A, invalid thing, you may say no. You may be silent also. See, S1 on B, you may not write dead state, means silent, means not going anywhere. But here you have to respond. Valid, yes. Invalid, no. Valid, yes. Yes means final. Invalid, non-final, no. Here, valid, final. Invalid, no or silent. Right, like that. Perfect. So I think I completed 5 problems. Tomorrow I will complete 10 more. Right? Please be careful. Tomorrow I will complete 10 more. Right? Fine. Thank you. See you in the next class. See you in the next class. I think let me complete this also. Yeah, I think perfect. Tomorrow we'll see. Here I am stopping. See you in the tomorrow's class. Bye. Bye, bro.